Hi everyone. This video is Cambridge Primary Mathematics Learners Book 6, Unit 2, last subtitle 2.3 Common Multiples and Factors and Exercise 2.3 and check your progress. အားလုံးပဲမင်္ဂလာပါဒီဗီဒီယိုလေးကတော့ Cambridge Primary Mathematics Learners Book 6 ရဲ့ Unit 2နောက်ဆုံးပိုင်း Common Multiples and Common Factor Exercise 2.3 ကို sharing လုပ်ပေးထားတာဖြစ်ပါတယ်အားလုံးပဲသုံးဝင်ကြပါစေ Okay, this is subtitle 2.3 Common Multiples and Factors. So we are going to find common multiples and we find common factors. So important words are common factor, common multiple, factor, and multiple. So you have to know the difference between what is factor and what is multiple. Okay, combining these two words. So imagine you have this bar of chocolate. You divide it between you and your friends. So you all have the same number of pieces. Okay, how can you divide your chocolate bar between your friends equally? Okay, let's count the pieces first. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So 4 times 6 is 24 altogether, 24 pieces. So we have to think about factors of 24. Okay, so you can divide it equally between 2 people, 3 people, 4 people, 6 people, 8 people, and 12 people, or 24 people. So how can we get these numbers? So they are factors of 24. Okay, what about 2 people? So 2 times 12 is 24. So for 2 people, each one will get 12 pieces each. For 3 people, 3 times 8 is 24. So 3 people will get 8 pieces each. For 4 people, 4 times 6 is also 24. 4 people will get 6 pieces each. For 8 people, each will get 3 pieces. And for 12 people, each will get 2 pieces each. For 24 people, each will get 1 piece each. Okay, so we can say that 24 is a common multiple of 2, 3, 4, 6, 8, 12, and 24. So 24 is a common multiple of these numbers because we can make 2 to 24 with multiply by 12. 2 times 12 is 24. 3 times 8 is 24, and 4 times 6 is 24. 6 times 4, 8 times 3, 12 times 3, 24 times 1. So they are factors of 24, and 24 is their common multiple. Okay, in this section, you will learn about common multiples and common factors like this. Okay, watch example 1. Example 3, Anna is thinking of a number. She says, my number is a multiple of 3 and 5 and is less than 20. Multiples of 3 and 5 and is less than 20. So what number is Anna thinking of? So we have to find out what is Anna's number, okay? So first step, we have to write down multiples of 3 first, which are less than 20, okay? 3, 6, 9, 12, 15, 18. Another one is 21. 21 is larger than 20, so we stop here. And then multiples of 5, they are less than 20. So 5, 10, 15. Another one is 20, 20. We won't take it, okay? So we need to find a common multiple of 3 and 5. So the answer must appear in both lists. So the one appear in both lists are 15, 15, 15. So our answer is Anna is thinking of 15. 15 is common multiple of 3 and 5. So it can get by, we multiply 3 and 5 also. 3 times 5 is 15. So we can find because 3 and 5 are prime numbers. So if we multiply them, we can get common multiple. And exercise 2.3. Okay, number 1. Write the numbers in the correct place on a copy of the Venn diagram. So the numbers are 5, 40, 50, 80, 20, 21, 24, 29, 30, and 60. So there are three circles, multiples of 2, multiples of 3, and multiples of 5. So which numbers are common multiples of 2, 3, and 5? So let's check the number one by one. 5. I cross out each one if we have done 5. 5 is only multiple of 5. So we have to write down 5 here. 40. 40 is multiple of 2, not 3 and 5. So 40 must be here. And 50. 50 is multiple of 5 and 3. So we have to write the middle place of 5 and 3. 15 must be here. And 18. 18 is an even, so it is multiple of 2, multiple of 3, not multiple of 5. So we have to write between 2 and 3 between them. It is 18 is here. 20. 20 is even, so 2 and 5, not 3. So 20 must be here. And 21. 21 is only multiple of 3 only, not 2, not 5. So 21 must be here. 24 is even 2 and 3. 2 and 3. Okay, 24 is here. And 29. 29 is a prime number, not the multiple of all of them. So 21 must be outside the circles. So 29. And 30, 30 is an even 2 and 3 and 5. So 30 must be here. And again, 60 is multiple of 30. So it is 2, 3, and 5. So 60 is also here in the middle. So our answer is which numbers are common multiples of 2, 3, and 5? The common multiples for all of them must be in this region. Okay, our answer is 30, sorry, 30 and 60 are common multiples of 2, 3, and 5. Okay, exercise 2. The numbers in this sequence increase by 3 each time. It means they are multiples of 3, 3, 6, 9, 12, and so on. The numbers in this sequence increase by 5 each time. So 5, 10, 15, 20. So both sequences are continued. Write a number bigger than 100, which is in both sequences. A number bigger than 100, which is in both sequences. So the number must be larger than 100. So if we continue our 3 multiples, it will take a long time, and 5 also. So we can do shortly by multiples of 3 and 5 at the same time. So 3 times 5 is 15. So we can do by continuing multiples of 15 to get the number larger than 100 in a shorter time. Okay. Okay, so 15, 30, 45, 45, 60, 75, 90, 105, and 1, 105, and 1, again, 120. Okay, a number bigger than 100, which is in both sequences, is 125 or 120. So it is 105. So write all the common multiples of 3 and 8 that are less than 50. All the common multiples of 3 and 8 that are less than 50. So at the same time, we can do just like number 2, 3, and 8 common multiples of 3 and 8 less than 50 is 3 times 8 is 24. So 24 times 2 is 48. So 48 must be a common multiples of 3 and 8 less than 50. So our answer is 48 for number 3. Okay, number 4, Olivia and Anya play football regularly. Olivia plays once every 4 days. Anya plays once every 3 days. So if they both play football today, how many times today and how many times in the next fortnight will they play on the same day? Okay. How many times in the next, for as a after how many days will they play again together on the same day? Okay. It means that we have to find out a common multiple of 3 and 4. So common multiple of 3 and 4 is only 12. Only 12. Okay, let's check. 4 is 4, 4, 8, 12, 16, sorry, 16, 16 and 20. 3 are 6, 9. Okay, we can see 12 is multiples of common multiples of 3 and multiple of 3 and 4. So they can play um, after 12 days from today. They can play together again on the same team. Okay. So 12 is a common multiple of 3 and 4. So they both play football on the 12th day, which is one time in a fortnight. On the 12th day. Because the common multiple is 12. Okay, this is answer for number 4. Number 5, write the factors of 18. Write the factors of 24. Draw a ring around the common factors. So let's write down. Common factor 18 is 1, 2, 3, 6. And for 24, 1, 2, 3, 4, 6. So draw a ring around the common factors. So 1, 2, 3, and 6. They are common factors of 18 and 24. Okay, number 6, write all the factors of 30 that are also factors of 20. Write all the factors of 30 also that are factors of 20. So factors of 20 are 1, 2, 4, 5, 10, 20. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. So we can choose 1, 2, 5, and 10. Okay, 1, 2, 5, 10. They are common factors of they are common factors of 30 and 20. It means factors of 30 that are also factors of 20 means they are common factors of 30 and 20. They are 1, 2, 5, and 10. Okay, number 7, Pierre gives 32 football cards to his friends. He shares them equally so all his friends have the same amount. He shares them equally just like the examples for chocolate bar equally so his friends have the same amount. So how many friends could Pierre have? Explain your answer. How many friends could Pierre have? So it means we have to find out common factors of 32. Okay, common factors of 32 are 1, 2, 4, 8, 16, 32. He can share the cards equally between their friends as 1, 2, 4, 8, 16, and 32. For 32, each one will get one card. 16, each will get 2 each. 32 will 1 each. And for 8 friends, each will get 4 each. Because 8 times 4 is 32, 16 times 2 is 32, 1 times 2 is 32. Okay, this way we can share his friends between them. Okay, number 8, Isabella has 3-digit cards. 3-digit cards, 1, 5, and 6. Which 2 cards would she use to make A common multiple of 5 and 13. Common multiple of 5 and 13. So 5 and 13 are prime, so we can find them common multiple easily by multiplying them. 5 times 13 is 65. Okay, so two cards for part A is 5 and 6 because we want to make 65. So part B, a common factor of 60 and 90. Common factor of 60 and 90, it is only 15, so 1 and 5. So 15 times 4 is 60. 15 times 6 is 90. So 15 is common factor of 60 and 90. So she has to use 1 and 5 for part B. She has to use 5 and 6 for part A. Okay, 5, 6 is 65. 1, 5 is 15. Think like a mathematician. The sequence 4, 2, 1, 3 uses the numbers 1 to 4 so that each number is either a factor or a multiple of the previous number. A factor or a multiple of the previous number. Each number is used once only. Find a similar sequence that uses the number 1 to 6. 1 to 6, 1 to 3, 4, 5, 6. Here is 1, 2, 3, 4. So 4 becomes 2. So 2 is a factor of 4. And 2 becomes 1. 1 is also a factor of 1. 1 times 2 is 2. 1 times 3 is 4. Or 1 times 3 is 3. Okay. 1 becomes 3. 3 is a multiple of 1. Let's check. 4 becomes 2. 4 is 2 times 2. And 2 becomes 1. 2 becomes 1. So 2 is 1 times 2. 1 is a factor of 2. And 1 becomes 3. 1 becomes 3. 3 is 1 times 3. 3 is multiple of 1. Okay. This way, one possible way is we have to use number 1 to 6 is we can start from 5, 5, 1, 3, 6, 2, 4. So 5 becomes 1, 5 and 1. 1 is factor of 5. 1 becomes 3. 3 is multiple of 1. 3 becomes 6. 6 is multiple of 3. 3 times 2 is 6. 6 becomes 2. 2 is a factor of 2. 2 times 3 is 6. And 2 becomes 4. 2 times 2 is 4. 4 is a multiple of 2. This way, we can write sequence like this. So look what I can do. I can find common multiples. Common multiples, yes. I can find common factors, yes. Okay, this is check your progress. Number 1, Tyson counts in steps of 0.4. Counts in steps of 0.4 means plus 0.4, increase 0.4 each time. His first number is 1. He counts 1, 1.4, 1.8, and so on. What is the 10th number in his sequence? So we have to continue by adding 0.4 each time up to 10 times. So his sequence is 1.8 plus 0.4, 2.2, 2.6, 3, 3.4, 3.8, 4.2, 4.6. So the 10th number in his sequence is 0.6. This is his 10th number. Okay, number 2, part A, find the position to term rule for the numbers in this table. Position 1, 2, 3, 4, terms are 7, 14, 21, 28. So 1 becomes 7, means 1 times 7. So 2 times 7 is 14. Okay, 3 times 7, 21. Okay, 4 times 7, 28. So position to term rule for the numbers in this table is multiply by 7. Okay, part B, what is the 10th term of the sequence 7, 14, 21? So 7, 14, 21, 14, 21 are multiples of 7. So our 10th term for this sequence is easy 70. 10 times of 7, 70. Okay, number 3, which of these expressions are equal to 7 squared? 7 squared, you can see 7 squared. Which of these expressions are equal to 7 squared? 7 times 7, so this is correct. 7 squared is multiply 2 times of 7. 7 plus 7, no? Multiply 2 7 times, no? And adding 7 7 times, this is correct. Because multiplying is adding repeatedly. 7 squared is adding 7 7 times. So this is correct. 7 times 2 is only 14. No? 7 times 7 must be 7 squared. 7 times 7 must be 40. Okay. So 7 times 2 is only 40. It is equal. So the correct answer is 7 times 7 and adding 7 7 times. 2 and 7. Correct. Now, for Mia is thinking of a number. She says, my number is an even number, less than 50. It is a common multiple of 3 and 7. What number is Mia thinking of? Her number is even. So we can check easily because 3 and 7 are prime. So we can multiply them to find the answer faster. Okay, 3 times 7 is 21. So we can make double of 21. 21 times 2 is 42. So 42 is multiple of 3, multiple of 7. 7 times 6, 42. 3 times 14. So 42 is, another time is 63. So less than 50. So we have to stop here. 42 is a common multiple of 3 and 7, less than 50. Is that this? 42. Number 5, Tim goes to school. His age is a cube number, and his age is double one square number, double of one square number, and half a different square number. So let's think about square numbers and let's write down square and cube numbers first. So first square is 1. So we won't write 1. Let's start from 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. And his age is a cube number. And then cubes are 2 cube is 8, or 3 cube is 27. Okay, this is 2 cube. This is 3 cube. 4 cube is 64. So Tim goes to school, so he must be his age must be less than 10. Let's think about the number less than 10. So it's a cube number. A cube number less than 10 is 8. Let's think about 8. So 8 is 2 cube is 8. So his age is double one square number. Double one square number. One square number. Double of one square number. So we want to get 8. Half of 8 is 4. So we can double 4 to get 8. 4 times 2 is 8. Double a square number, one square number. 4 is 2 square times 2 is 8. So this up to here is correct. And half a different square number. Half a different square number. We have to take the difference of 2 square number and half of them. Okay, what about 16 and 9? 16 minus 9 is 16 minus 9, or 16 minus 4. Half a different square number. Sorry, half a different square number means another square number, half of another different square number. So if we want to get 8, double of 8 is 16. So we can make half of 16 is 8. Okay. So it is a cube number. 2 cube is 8. And double one square number. 4 double of 4 is 8. And half a different square number. Another square, half of another square number. Half of 16. 16 is 4 square. So how old is Tim? So his age must be 8. 2 cube. 8 here. He is 8 years old. Okay, this is end of Unit 2. Thank you so much for your attention and for your watching. See you in the next video for Unit 3. Thanks again.